All right, so let's review. When we're solving an equation, for example, 2x minus 1 equals 5. How do we know what to do when?
PEMDAS.
Close. Backwards PEMDAS. SatMap. Yes, sir.
SatMap.
All right, so we are solving today, but we're going to take it a step further. So let's go through just an easy one, a linear equation first. What do you do first?
Plus 1 on both sides.
Plus 1 on both sides. And you add 1 to the negative 1 because it cancels out because they are what?
Like terms.
Addition and subtraction are opposite operations, right? They're inverse operations that cancel each other out. All right, so we got 2x equals 6. Now what? Now divide by 2 on both sides. Okay, because multiplication and division are opposite. Trey, I need you to control yourself. All right, so far we have talked about these two are opposite operations, these two are opposite operations. Tell me, if I happen to have an exponent of, let's say, 2, what is the opposite operation there? What cancels it out?
2.
A square root. This cancels, yes? Let's say I had x squared equals 9. And I told you to solve that for x. And remember, I'm going SatMap, but this is a single step equation here. But what would I do to get rid of that squared? So tell me, what does x equal?
3.
Close.
3 to what?
Square root of 9 is square root of 9.
What'd you say?
8 to 1. X equals 3. Right? Yeah.
Somebody said it over here. 3 is only half the answer.
Or negative 3.
Or negative 3.
Okay.
You with me now? So we can write it like this, but understand that means either or, okay? That's 2 separate answers there like that. And this is going to really be important when, let's say, we have something like, this is fun.
Hey, could we just write it like that the first time?
This? Yes. It is fun, DeAndre.
So you tell them that I can go to sleep and wake up and do it like I did yesterday?
I don't know about that. Look at this one. Look at this one.
That's the formula for me dropping out.
No way. We're going to do this together.
So the x cancels out.
All right, so look, because here's where you really have to pay attention to your order, right? Because our brain always goes to the addition subtraction first, but that addition subtraction can't be sitting inside parentheses because whatever's inside parentheses is dead last. Okay? So when I look at it like that, what's the first thing that I need to take care of?
The exponent is inside.
The square root. Now, let me digress for just a minute. I'm kind of glad you said that because I want to show you.
What is the square root? There's a square root.
When we have something like this, we cannot just distribute that exponent through. Okay, you can never do that inside. Because x plus 1 squared is the same thing as x plus 1 times x plus 1. And if you were to FOIL that out, remember foiling? Distributing x times x is what?
Squared.
Squared, thank you. X times 1? 1 what? X times 1. So it's just x. 1 times x. And 1 times 1.
What are you doing, Miss McGee?
Oh my goodness.
Outside, inside, last.
Everything comes.
Let's take a pause. And let's take a pause. Let's digress a minute.
Go back.
I'm rewriting it right here. I will go.
Get a little refresher.
Listen, Because you have to be able to successfully multiply two binomials to be successful in this class, okay? These are two binomials, okay? Now, when we have two things that are multiplied, this is where I was telling you this is x plus 1 squared, okay? And the reason I'm showing you this is because somebody said, why don't we just put that squared to both? And you can't do that, and I'm showing you why you can't do that, okay? When you multiply these two out, someone at some point in your math career should have shown you, I like to just call it distributing because you take the first term in the first set of parentheses, or maybe you learned FOIL, and you multiply both first terms together. However you learned it, okay? I'm going to distribute this to this set of parentheses. So what is x times x?
2 squared. 2x.
X squared. X plus x is 2x, but x times x is x squared. How about x times 1?
X.
Now, this term has distributed to everything in this set, right?
And then plus
X times 1 is 1x.
Correct.
Plus 1.
I'm putting my 1.
Okay, you can put the invisible 1 if you want to. That's fine.
1 times x.
Now I go to this one.
X.
1 times x. 1x.
You got 1.
1 times 1.
Plus 2. I mean 1. I'm thinking about adding.
That's okay. All right, so now we're going to get our like terms together, and we have x squared plus, how many x's do I have? Now we're adding. 2.
That's not the same thing.
It's not the same thing. That's why you can't just take that squared through.
So I'm supposed to do.
Okay. I'm gonna have you some practice on multiplying some binomials. Yeah, we might need to do a side lesson tomorrow.
See, that's why some people have all that stuff. This making sidetracking into something else. Well,
All right, let's go back. Let's go back to this. Okay? I showed you all that to show you that you cannot just distribute this squared inside. Very on. Now, my key to you is to tell you that if you only see x one time in the equation, you can solve it by using SADMAP, okay? Inside parentheses is last. So what do I need to take care of first? Well, there is none outside of parentheses, the square root, right? Does everybody see this squared here? You told me the opposite of squared is what? Square rooted. So since it's squared is to everything, can I do that and have it cancel? Sure. But if I do it to this side,
Square root of 64.
So you can just divide them? Like,
you can just square root both sides as long as that squared's going to everything.
so why is it square root?
I did it right there.
No, I mean like, wouldn't it be like square root of x and square root of 1?
Again, you can't know because these parentheses tell you that that squared applies to everything on that side. Everything in parentheses that squared's applying to. So I just applied the square root to everything on top of it, and so it cancels out. Now listen, if it had looked like this, I wouldn't have been able to do that first. I'd have had to move the 1 first.
Now just make things even. No.
But no, because y'all are getting, look, y'all did this though.
What's the
We did it on one of them, I thought, maybe not. Okay. All right, we're going to practice. That's what I'm teaching you. I'm teaching you how to go to SADMAP. This is a whole separate problem. That's not the same problem.
Do you play our video for your 4th block? Or
Yeah.
pick another one?
All right, what's your video? What's the square root of 64?
You just play it and sit back, you're like,
Square root of 64.
Look, what is the square root of 64?
8 times 8 equals 60.
What is the square root of 64?
8. Or -8.
or -8.
Man, you get me confused with that thing.
Wait, so do they hear us?
It's got to be plus or minus if they watch the video. I teach, just like I teach you. All right, look.
Yep.
Is x by itself yet?
No, you still got -1.
-1.
So the answer is -7.
That's what and I talked to some of them, and they said you love to just flame us over out here.
I'm not quite done with this one, and the reason is I need you to understand
You said all. You asked me your next day?
that this is +8 minus 1 or -8 minus 1. That's why it's plus or minus.
So it could be either one.
So you get 2 answers for these. Listen, because I'm showing you places where students always mess up. You don't subtract 1 and throw a plus or minus in front of it. The plus or minus only goes with the 8, okay? So then I have to split this up into 2 separate answers, +8, -8, and finish solving it.
So where you getting 7 and 9 from?
Plus or minus 8 minus 1. Plus 8 minus 1, -8 minus 1.
I get it.
You see? Yes. All right, let me show you another one. We're going to keep practicing with this. Let's say I had x squared minus 5 equals 31. Okay, well, so this one's different, and understand why this one's different, okay? If I'm talking about SADMAP, parentheses are last, right? But I don't have any parentheses here. So I can just run straight through SADMAP. Do you see that? Do you see why this one's different?
Yeah, I guess.
The other one looked like this. What was over here? I can't remember. 64. This one's different because there was a set of parentheses here. This one has no parentheses. So since there's nothing in parentheses, I'm good to just go straight through SADMAP, okay? So what do I do first?
You're gonna
Plus
add
5.
5, and then you're gonna get 36, and you're gonna root, which will give you x2 squared, 36, then square root both of them.
That's boy.
That's right.
Then you get 6, x equals 6.
That makes sense. All right, so square root on both sides to get rid of the squared.
Then you get x equals 6. Positive or negative.
Thank you. Plus or minus 6. Okay, so what that means is x
And
could be
after you do that,
6.
You put x equals -6. But you also can do it like you did the last time you do
Which one?
x equals no. Yeah. You see what I'm getting at? Show you.
So basically, it's just like doing SADMAP, and you work your way down to the x. You work
Yes.
your way down to the x, and then
Yes, absolutely.
See reference. See what you did.
Okay, let's do another one. 3x squared. Do not think just watching this, guys, and you go, oh, well, that makes sense. If you're not working it with me and working through, you're not going to get it. All right. All right. Shh.
Yeah, what did he do?
I'm going SADMAP. Okay. So I'm subtracting 5 first. Absolutely. So when I move the 5, I get 3x squared equals, what's 41 minus 5? 36. Well, that's the question. All right, so look, we did the addition subtraction. So the question is, can we go ahead and square root here? Because that's looking like a pretty nice perfect square there.
We can divide it by trace, and then you will get.
I cannot take the square root here because look at the order. I have to do multiplication division first. This is why we have to know this order, okay? Now, if it looked like this, that's different because parentheses are last. But because there's no parentheses, that squared is only hooked to the x. It's not hooked to the 3.
So the answer is going to be x2
Yes.
Lexi.
Where do you get 12 from?
Okay.
Hold on, guys. Focus. Yes.
Like without a parentheses, we can square root, but if we had the parentheses, square root.
Yes. Yes. Absolutely. Yes. Square root. Yeah. All right. Let's take it a step at a time. A step at a time. Does everybody see why I am dividing first and not taking care of the exponent? You look at the order, multiplication division comes before the exponent. So I'm going to divide by 3. You got to simplify it. Okay, now watch, because here's where you got to learn, you've got to use what we learned the past couple days, okay? Obviously, there's only one thing still hooked to x, and that's what?
2.
That's that squared, that exponent, right? So what I want to do is take care of it. How do I take care of it?
Mark it out.
Yes, square root it.
12 is not a perfect square, so you're going to use 4 times 3.
This is where exactly. I've got to break it down like I've been doing. How do I do what?
How do you get that answer?
This is gone now. Okay? So now 12, I need to look at that list of perfect squares, these orange numbers behind me. What's the biggest one I can divide 12 by? 4. 4 times 3 is 12, right? The square root of 4 is 2 times the square root of 3, and don't forget your plus or minus in front.
You just choose 3.
That's it.
The problem. Did you choose 3?
Can we do another one?
Taylor and Maya, y'all need to wake up. Wake up.
I'm not asleep, man.
I didn't say you.
Man, bro, I'm mad.
All right. Shh.
I'm tempted.
All right. That's okay. It's all right. It takes practice, guys. Don't get frustrated with it.
How can you not get it? It's hard.
Trey. This one's gonna be pretty difficult. No decimals. Okay. If you get something, leave it as a fraction, and you'll see what I'm talking about. This is gonna force us to use all those things we learned the last 2 days, and you'll see why when we go. Well, you can't distribute because the exponent would come first, and I would have to write that twice and multiply it out. So I can't do that.
Will we do it backwards?
3x.
Do what backwards?
6x.
And go from left to right.
All right, look, first of all, look. How many times do you see x written in that equation?
Once.
Just once, right? So I'm going to work backwards from SADMAP. Parentheses are last, right? Absolutely last. So do you see any addition or subtraction outside of the parentheses? Okay, so I'm good with that. Do you see any multiplication or division outside the parentheses? What? That 3. Okay, now
Divide it.
be careful. That's gone, right? 3 doesn't go into 40.
Basically, we're just trying to.
Okay, hold on a second.
13.3
Yes.
represents.
If there's parentheses, yes. All right, where'd I lose you?
At everything.
So this, what we do with the exponent?
I haven't messed with the exponent yet. The exponent's going to come next. Right now, always work outside the parentheses first when you're solving.
And then you always have to get rid of the one outside.
Yes. All right. Yep. Keep it 40 over 3. Yes. No decimals here.
Or not decimal, what would it be?
It would be a decimal.
Like that.
Leave it like that. And I think you're going to see why in just a second.
Now you cancel out with your square root, and then you
Everybody agrees square roots are next, yes? Because exponents come next. Now watch what happens. This is why we've spent so long on these properties of exponents. Look what happens. This side looks like your homework from last night, does it not? So, oh my goodness, take a second. Let's take a second. Let's come over here. The square root of 40 over 3. Can you break anything apart?
No.
40. You can break that 40. What's the perfect square that goes into 40?
Quattro.
4 and 10. Some of you are saying 10 and 4, 4 and 10. Okay? So this is the square root of 4 times the square root of 10, which is, are we all in agreement there? If you don't even look at this half of the equation, you just look at this, all I'm doing is simplifying that radical. What was your question? We will at the end. Yep, we will at the end. We do. We're fixing to do that. What's your question? Yeah, Andre.
Who is looking? I am.
You want to talk about me, because I am looking.
Say again.
Where you get that from?
You add or you?
We're going to multiply, but we're going to do that in just a second. Let's take it step by step. We broke the 40 down.
So you said you got a concept that can go into 4 even.
40. One of the orange numbers back here.
3's not even there. You're just looking at 40. That's all you're looking at. And you're just trying to reduce it down to like smaller numbers
Right.
so you can multiply.
We just simplified it, just like we did when we broke them apart. Does everybody see where? Look, square root of 40 is the only thing I've worked with here. That's the only thing I've changed as I went.
Yes.
You see that? Are y'all with me? All right. So now let's look. Now we got 2 root 10 over root 3. And a lot of you have said that square root of 3 is bothering you. It's bothering you because it can't be there, right?
Plus or minus, right?
There is a plus or minus, yeah.
So you're going to multiply from 2.
Exactly. I'm going to multiply the top and the bottom by that square root. That's what we did yesterday. You can't have a radical in the bottom. Yep, you weren't here yesterday. So I got 2 times the square root of 30.
Over 9.
Outside too. That's why you.
That's been here. That's where we split it apart. 30 won't break down. There's nothing that goes into 30. Because we broke it down in the beginning, it should be good enough.
Why you can't do 10?
Huh?
You can't do 20. That's why.
So
Well, 10 and 3 won't work because 10 or 3 are not on this list.
So when you multiply,
Oh.
It's got to be a perfect square.
when you multiply this.
Okay, so what do we do with the x
Yes.
minus? What do we do with the x minus 2?
Okay, so everybody agrees all we've done here is simplified this right side of the equation, right? That's a lot just to simplify that right side. All right. So now's the easy part. I've got x minus 2 equals 2 square root of 30 over 3. And there's only one thing. This is a plus or a minus. What? Add 2. You're absolutely right. Here's the nice thing about it. When this is not a whole number and it's a big yucky fraction like that, when I add 2, you can just say x equals, I'm going to put the 2 in front, 2 plus or minus, and write that fraction. You don't have to actually do it. You can leave it like that.
That makes sense. I understand on the left side why you did it. But the right side, where you get it, what you did.
Teachers, please send 10th graders of the last.
It is fun.
You said it's fun.
I think we have different definitions of fun.
Can we do like just a whole number one?
Do you actually think math is fun?
I do. I love math.
You really gonna give us fraction? We don't even get the whole number yet.
So
Well,
you're telling me
but-
when you were growing up and you were taking your math classes, you're like, I love this.
Yes.
5 and 7.
Okay, well, what you just asked me, how do you divide a fraction into a number? Remember, absolutely, good job. Remember when we were reviewing about fractions, we never divide by a fraction.
You don't understand.
Look, DeAndre, what I'm getting at is the fractions going away. If you multiply by the flip, I got x plus 3 squared equals 35. To get rid of a fraction, instead of dividing by the fraction, we multiply by the reciprocal.
You get 5.
7 times 5.
Well, okay, what you gonna do again?
7, top times top, bottom times bottom. They're both over 1. And that's okay. That actually, even though it looks bad, it's easy for us. Did y'all hear the question? When we square root it, does everybody see that we square root next? When we square root it, there's nothing that goes into 35. There's no way to break it down. Okay, then I just throw a plus or minus in front of it and write it like that. I square rooted. If you can't do it, write it, okay? And what I mean by that is, whenever I subtract the 3, I can't subtract 3 from square root of 35 without getting decimals and all. So I just write it on the side, absolutely. So look how easy that problem turned out to be.
So we try one?
Yes, let me give you one to try. I'm going to give you one off of your homework set to try.
I'm gonna tell you right now, right now homework you didn't know we did it for
DeAndre. We're doing the harder, they're not all on your homework as hard as what we're doing the examples in class, because y'all asked me to do the harder ones with you in class. Nobody's talking about you.
Yeah, you better not be.
DeAndre, we love you.
Black, white, don't talk about me.
Okay, back to this one. X minus 4 squared minus 18 equals 10. All right, try this one on your own. This one's not, it's not going to turn out as bad as what it looks. Sad map. Sad map. You got to remember sad map. This has got one of everything in it to try to help you out. I'm going to pause the video so y'all can work a minute. All right. Look, because I want you to, guys, I want you to follow my process as I work through this problem to help you as you work through the ones tonight, okay? The first thing I want to do is any addition or subtraction, remembering that parentheses are last, and somebody made a good point. They said, so we should just kind of treat the parentheses like a variable and get it by itself, and that's absolutely right, okay? That was a good point. Good job. All right, so addition or subtraction outside of parentheses, do you have it? Yes, that 18. Does everybody agree? How do I get rid of that 18? All right, so it's gone here, yes?
Yes, 28.
So on the left, I've still got 7 minus x squared equals 28. Is anybody confused at this point? Okay. I've done my subtraction and addition. Is there any multiplication or division now? 7. So I need to get rid of it. How do you, so you divide on both sides. Absolutely.
Go ahead and get rid of 7.
Something easy.
Now,
The 7s are gone.
It's 4.
You just do the square root.
28 divided by 7 is 4.
I was doing it like just 7.
So x equals 2?
Close. Plus or minus.
Okay. So I think we lie that.
So now you do
So x equals positive or negative 2?
Not x doesn't know. Hold on. Watch us. Watch us. All right. My exponents are next, right?
Yes.
So how do I get rid of that exponent? Square root. Now here's where you have to be careful. Because the square root of 4, and somebody asked where this went, these cancel. The square root of 4 is what? Or, okay, So understand what that means. That means, I'm sorry if you weren't. Go back up.
Plus 4,
You do set one of them equal to positive 2.
and negative 6.
Set one of them equal to negative 2, because it could be positive 2 or negative 2. You should get 2 answers. The reason, listen, the reason we didn't do that before was because it wasn't a whole number. It wasn't a perfect square. The square root didn't go away, okay? But here it did, so I can solve each one.
You have a perfect negative 2 and negative 6.
Positive 2, positive 6. Now, if you had come here and you had said x minus 4 equals plus or minus 2, and you added 4 to both sides, x equals 4 plus or minus 2, that's the same thing. I want you to realize that those two answers are 4 plus 2, which is 6, or 4 minus 2, which is 2. If they're whole numbers like this, I want to see that you actually know what those numbers are, because we're going to be doing something with those later when we get into graphing. I told y'all this builds. You can't get behind in any one section.